In this video, we're going to introduce what's called the solubility product. The symbol for the solubility product is KSP. KSP, or solubility product, is an equilibrium constant for dissolving a solid, most likely into water. So we take a solid, we dissolve it into water, and that would give us the KSP. So some solids dissolve very easily in water in huge quantities. So for example, sodium chloride, table salt, dissolves really well in water. You can put quite a bit of it in and it dissolves, but other salts or other ionic compounds do not dissolve so well into water. Only a small fraction of it will dissolve, maybe 1% or 0.1%. So when small amounts of a solid dissolve into water, that's when we look at the solubility product. So let's take a look at a picture or a diagram of what's happening here. I'll draw a little cartoon of this. Okay. So the idea would be that we have a container with water in it. And then next to it, we have some solid. Okay. And we're going to assume it's an ionic compound. And we try to dissolve it into the water. And what you find is that for some of these ionic compounds, most of it just stays as a solid. It just is most likely more dense than water, so it'll just fall down to the bottom, just sort of sit there. But if you analyze the water above it, what you'll find is that even for solids that are not very soluble at all, there will be some of it dissolved, a small amount. And what's happening is a dynamic equilibrium. The ions of the solid that are dissolved in the water will collide with the surface of the solid and reprecipitate, reform a solid. And at the same time, ions that are in the solid will dissolve at the surface of the water and go back in. And if you allow it to equilibrate, you allow it to have some time to become stable, what you'll find is the concentrations of the ions in the water are stable, as long as the temperature doesn't change or chemical conditions. And the amount of solid that you have at the bottom will stay pretty stable. Now, that doesn't mean that nothing's happening. At the surface, ions are dissolving and reprecipitating back and forth. This is a dynamic process. But over time, what we find is that there's a stability in terms of the concentrations of the ions in the water. And when we think of concentrations and stability, we often think of equilibrium processes. So that's what we're going to do. We're going to approach this with an equilibrium process. So we've talked a lot about acids and bases, but this is actually a related but different phenomenon. We're talking about the dissolving of solids into water. Okay, so let's take a look at an example here. I'm just going to go right to a problem so that you can see it. What it says here, it wasn't clear to me when I first read this question what they wanted, but it says complete the following solubility constant expression for MgOH2. So what I'm going to do is I'm going to do two things. I'm going to write out a chemical equation, and then I'm going to write out the expression for KSP. When someone says write the expression for an equilibrium constant, what they mean is K equals concentration of something times concentration of something, you know, the products over reactants, right? But for KSP, it's an interesting phenomenon in terms of how the expression looks. So I'll show you in just a moment here. So this is for MgOH2. So let's go ahead and do this. I'm going to, again, as I promised, I'll write the chemical equation first. And what you do is you write the chemical formula of the solid, and then you write a double arrow. This is going to be an equilibrium process. And then you break it up into the ions that are in the solid. So the magnesium is in group 2A, so that's +2. Hydroxide is a polyatomic ion that has a charge of -1. So we're going to get Mg2+. And then notice you have a 2 there. So that 2 is going to come out in front of the hydroxide. Okay. So now, here's how we write the expression. The expression is typically written as KSP equals. Now for equilibrium, remember we do products over reactants, right? Products over reactants. So the first product is the magnesium ion, and make sure that you write the charge of it. So the concentration of magnesium ions times the concentration of the hydroxide ion, but again, it's an equilibrium expression, so you get that 2 there, that becomes an exponent. Now, this is a solid. So this is an example of heterogeneous equilibria. Remember, solids and liquids are not included in equilibrium expressions. So that would be our answer right there. We would have magnesium ion concentration times hydroxide concentration squared, solubility, right? We're talking about the solubility. And notice, you can think of it this way. We're just multiplying numbers together. There's no division, right? Because there's nothing on the reactant side that we're going to put the expression. So that's a product. When you multiply things together, that's called a product. You can also think of it in terms of we're only putting the products in, it's a solubility product, right? So either way, you want to remember that. It's just the products, not the reactants, okay? And so what that tells us is if we want to know what the value of K is, we would need to know the concentration of magnesium ions, and we would need to know the concentration of the hydroxide ions. Let's take a look at one more example. Okay, so this is CaCO3, calcium carbonate, right? CaCO3. So again, we just need to know what the ions are. So I'm going to write out the chemical equation, and then I'm going to write out the expression for KSP. This one's a pretty easy one. Okay, again, you use a double arrow. This is calcium, it's in group 2A, so it's +2. And then this is the carbonate ion, which is 2 negative. You should just memorize the common polyatomic ions, and carbonate is one of them. So you have calcium concentration plus carbonate. So this is the chemical equation. And we generally want to put aqueous in there because these are ions dissolved in water. And then KSP, you just do the products. The first one is calcium, and the second one is carbonate. Okay, so there's your KSP, right? Now let me show you just real quickly one that's kind of huge in terms of the number of ions. So this is called calcium phosphate. And calcium phosphate has 3 calcium ions and 2 phosphate ions. So you have 3 calcium, so 3 Ca2 plus, and then you got your 2 phosphates, and phosphate is -3. Okay, so for this one, the KSP actually is pretty interesting. It's concentration of calcium, but there's 3 of them, so I'm going to cube it, and then times the concentration of phosphate, and there's 2 of those, so I'm going to square it. So that would be that's what we call the expression. Okay, so there's a little introduction into KSP. Next, in the next video, what we'll do is we'll start looking at some more involved calculations with concentrations and values of KSP.